Well, I guess in the interest of time, we might get started. I'm between you and well-deserved drinks, dinner, whatever it might be, and I'm not sure if there's any Portugal or Spain soccer fans in the room. If you are, good spirits. I'm not sure what the score is from the European soccer half final, I believe it is. So I'm lucky enough the Germans play tomorrow and I still don't care because I'm not really a big soccer fan. So today we figured we'd talk a little bit about cloud like you have to in every talk. But I will keep it to a hopefully good minimum here to talk too much about cloud, what cloud is. We've got plenty of talks to cover this. But really also talk about what we've got a fairly large portfolio now in Red Hat around Linux, around cloud management, virtualization, provisioning, all of those different things, storage, for example, just recently, and how, for example, you can use these technologies and sort of plug them together and maybe look at some new use cases, some new deployment opportunities, and some sort of ideas on how you maybe can change some of the implementations you've done in the past so you don't repeat over and over what you've done. But just to give you a sort of a grounding on what's happening, also what we also hear from customers, for example, which hopefully should resonate with you. So the good part is hopefully a lot of the stuff in the first couple of slides should not be news to you. You should have heard already a lot. And it's really infrastructure centric. So not going to talk a lot about middleware, JBoss, application side. We have Pierre Fricke, who I believe may have given or is going to give his talk about building an intelligent enterprise using JBoss technologies, which would be a very, very interesting talk to attend, which kind of sort of really then addresses the next layer up from building out the infrastructure, deploying technologies, and how you deploy these technologies over time and not have to do like rip and replace, but an evolution over time to build your more agile infrastructure. And also talk a little bit around standardization, how, for example, you can benefit from standardizing your environment onto commodity hardware, for example, commodity components, common APIs, common system builds, and again, streamline your operations and focus a lot of the work you do from sort of the mundane sysadmin task, repetitive task, to more value-added task, which is not only good for you in terms of efficiency, but also more interesting. Rather than doing the same thing over and over again, you suddenly can do some interesting, new, exciting stuff. And then, as I talk about our technologies and how they could be used and sort of some ideas we are bouncing around on what could be some of the new use cases around our technology, and hopefully have some time for Q&A. And obviously, cloud means a lot of things to a lot of people. If you probably talk to 15 people around cloud, you probably get 20 opinions on what cloud means to them. And I would say it always depends on from where you look at it. Very few people also look at the big picture. It's often, even today, still event-driven or, well, I need a cloud, so I need a self-service portal, so that's why I need to build a cloud. But for example, in our case, when you talk Red Hat Enterprise Virtualization, you already get a self-service portal part of it. So yeah, it's a private cloud. We just don't call it necessarily private cloud in all our collateral. But I think it is important to step back, look at the bigger picture, and really also look at cloud as not being a part number. Any vendor who tells you, oh, we have cloud as part number XYZ is not telling you the truth. There is not a part number for cloud. It really is an evolutionary process. It's not just technology. There's also a lot of business processes, for example, behind it, which is good because cloud is now pushing a lot of the challenges which we all ignored for many years as we implemented virtualization, because it was just so easy to virtualize, build virtual machines, put them on a server, run them. A lot of the other issues around chargeback, for example, business processes, all those things were kind of put on the side because, again, it wasn't as necessary. And suddenly now with cloud, it comes really to the forefront because you also suddenly have very different competition to your own IT organization. So, and this is just a very high-level sort of typical cloud technology stack you would expect any vendor talking to you about where you want to be able to run your applications anywhere and literally provide to your end user really a platform or a software as a service infrastructure, but the end user, the customer of yours, should not be caring or even knowing on from where you provide this service, where the resource comes from. If it's a local resource, even from where local it comes, if it comes from, say, a virtualized infrastructure, if it comes from a bare metal infrastructure, if it, again, comes from some other data center, comes from a private cloud, a public cloud, they should not care because they specify an SLA quality of service around it, and you guarantee they get this particular service level, for example. But you should be able to pick and choose where you place resources, where you get resources, how you flex resources, for example. You also need, of course, a very comprehensive management framework for your cloud infrastructure, for your IT environment, where, for example, you don't want to have these silos of management where each infrastructure component is managed with a separate set of tools, and you have to do things multiple times over. So as you deploy resources, as you create virtual machines or application bundles, you want to use a common set of tooling across all of these implementations rather than using individual tools all over, which makes it very hard to automate. But if you can abstract this layer, automation becomes much, much easier, for example. And then obviously, commodity infrastructure. We are not going to talk about any of the RISC platforms today, any of the what we call legacy platforms, but the assumption is today you standardize on x86 servers, use some virtualization platform, preferably, of course, Red Hat Enterprise virtualization, and then run virtual machines. And we also realize the world is not flat. You might not run just Linux virtual machines. We also support, of course, Windows virtual machines, and you should be able to mix and match those deployments as you see fit and as your service requires them. And that's why it's important when we talk about the application side, especially if you listen to some of the talks we have around OpenShift, on how you can build applications to be truly portable across not only infrastructure, but even different platforms, for example. Because now you move, a lot of the programming skills and capabilities are moved up a layer or two by now. Very few times you will find developers who really go down into the weeds, into C, C++, for example. Most of them will work with much higher level languages, much more portable languages, which is great because you have a much greater pool of resources as well and a much wider variety of applications, for example. And then on the side, you see this box around VM orchestration, which again is very important because now suddenly the complexity or dependencies between these environments might be very different than in the past, where in the past you set up, for example, failover environments. Well, you had two servers, application failover from A to B, for example, or an application relied just on the front end, very easy to manage. Now suddenly it's not only this dependency chain where you have a web server, middleware, for example, backend server, and they all need to start, stop in certain order. For example, you want to be able to flex, for example, up and down number of servers, number of instances, but all of these resources could suddenly be in different infrastructures. And you want to be able to define policies on how often, for example, a resource can fail in a certain infrastructure, and should it be restarted X number of times in a given infrastructure, and then maybe just be able to fail over to another infrastructure rather than restarting it in the same infrastructure over and over with very little success, for example. So I think fundamentally today, of course, everybody will promise you cloud solves everything and more, but cloud really doesn't solve everything. And a good example is Amazon. You probably hear it in a number of talks here at the summit as well. They, of course, gain a lot of visibility if, for example, some of their services goes down. I always say, well, you always notice if S3, their storage service, goes down because 75% of the world's internet pictures disappear and you only see red X's everywhere. But I don't think it's fair, for example, to blame them. Amazon went down, it's their problem. Sure, there was a problem in their data center, but it's just a different scale, but it's a similar problem which happens in every other data center many times over every day of the year. And many times, the customers affected are customers who put their stuff into the cloud and thought, oh, it fixes everything, including HA, DR, backup, whatever it might be, but actually it doesn't. You still need to cater for some basic architectures for architecture requirements, such as, for example, how do I fail over my application? How do I design DR, for example? And again, the good use case or proof here is with Amazon, customers who design their applications to run in multiple availability zones, they are not affected by those outages. Very, very seldomly, I should say. But they're usually not affected by these outages because, again, they've done proper architecture. So bad architecture cannot be fixed by cloud either. So fundamentally, I think future IT infrastructure and data centers will be managed in very similar ways as they are today. There's not going to be a momentum shift and suddenly things are totally different. They will evolve over time. There's certainly going to be the possibility of some more complexity, but fundamentally it will remain the same. But now suddenly IT is driven much more by business requirements and, for example, business pushing for true service delivery based on what they pay for. Because as I said earlier, suddenly there's other competition out there. If somebody, for example, from a department goes outside to Amazon, all they need is a credit card with $1 on it, for example, and they can spin up a VM for development, whatever it might be, and they don't have to haggle with the internal IT organization about IP addresses, storage, and we all have lived through this. It takes 2 weeks to get my IP address, takes another 2 weeks to get my storage assigned, for example. If I go to a public cloud provider, it takes me 10 seconds to get my VM, for example. And this creates a whole set of other problems around, for example, compliance, legal issues potentially, simple stuff like backup. All those things suddenly become real issues in your environment. But what you're measured on today is really the time it takes to bring resources online. Many years ago, we were all happy. We had like 2 months time to deploy a server, deploy an application. It all shrunk down maybe to weeks at some point. Now, I think you're lucky if you have the time of like a day or two to bring a server or a service online. Usually if somebody comes to your IT department, they want to have it online now, basically. 1 hour, 2 hours, whatever it might be. So it is much tighter service level agreements, tighter quality of service, but also a real need for predictable cost. Because in the past, IT cost often wasn't necessarily very transparent. And now suddenly, as there is competition to compare, people will look at, well, I pay this for this particular service, I pay X here, and I get less service, for example. So there is certainly a lot of interesting dynamics here. And there might be some new models around charging, not just a simple pay per hour, for example, those kind of things, but possibly down the road scenarios where actually there's loan and borrow scenarios, where departments have a certain set of resources they can use. Another department, for example, doesn't use their resources, and at a cheaper price, you can loan capacity. Amazon has introduced something like this already with their spot instances where you can bet on compute time, for example. And you already have probably seen some of the services out there offering broker services for cloud compute capacity. And this certainly has a potential to extend in the future as well, where again, suddenly you just ask for resources and you don't know from where they come, but you just care about the cost, for example, and again, an attached SLA. With open source, as Jim and many others said today already, you also as a customer have now much more influence into the actual product and into the community, for example, and its capabilities on where the product is driven, how, for example, you can get involved. And you can remain just a normal consumer of technology. You don't have to work upstream. But we do have customers who have worked with us upstream, very actively added features to, say, Linux, for example, other product components, and therefore also reduced their own burden in-house. Again, examples are some of the cloud providers where in the past they had, say, 400 different versions of the kernel. We've worked with them moving a lot of the features. They modified, they changed, worked with them upstream. Now they consolidate down to a handful of kernel versions, much easier to maintain. Same example again is Amazon as a cloud provider who run today on our RHEL 5 build hypervisor. We've worked with them. They actually use our standard build. They don't use any custom build of the hypervisor because, again, the value is not on building an operating system. The value is higher up in the stack, building tooling, building services around. And again, if you look at their feature velocity, You don't see them brag about, oh, we added this knob on RHEL or we added this knob on the hypervisor. They always talk about additional services they offer as services the customer can consume, and of course brings revenue into Amazon. And then clearly over the years, open source, Linux specifically, have driven commoditization tremendously. I always say, well, if nothing else, we turned Sun's $1 billion hardware business into a $300 million software business. And the same is you see happening with virtualization, where we introduce KVM as a hypervisor for free in RHEL because we don't believe you should be charged for the hypervisor, for the virtualization capabilities. The value is in the tools on the higher level. Same is now happening with storage, with Gluster, where you can use suddenly commodity hardware to build storage servers, storage pools, and it not only gives you a much, much lower price point, but it enables you now to look at some of the use cases you may not been able to address earlier because you didn't have the financial means to build a storage infrastructure, or you just didn't have the capability in terms of floor space, whatever it might be. So again, there are a lot of interesting opportunities here. So again, key today is what you would like to be able to do is leveraging a lot of the open source capabilities, the feature velocity, but also the ability to drive the price point down for the technology you're using and reallocate the budget. Not just reduce the budget and lay off people, but really reallocate the budget and use people more efficiently and for more interesting tasks. So rather than having all the people just keep the lights on, you throw the money into just maintaining current operations, be able to take some of the money to re-architect some of your applications, some of your infrastructure, look at some of the new technologies, such as NoSQL, for example. A lot of customers become very, very serious about now looking at re-architecting some of their database infrastructure. Is there an opportunity to move some of it into NoSQL space, for example, to break the stronghold to some of the traditional database vendors? So again, it gives you a lot of choice there as well. Then, of course, there are a lot of physical, environmental challenges for data centers today, IT infrastructure, as I said earlier, as simple as there's now competition suddenly out there where you can go to a third-party cloud provider, get resources. But also there are some markets out there in other countries who are very, very fastly, for example, emerging. You need to build up some new IT infrastructure. You don't have even the ability to, say, build a data center. You would like to be able just to deploy a virtualized IT infrastructure with some cloud provider, for example, to use the same tools you already use in-house, use the same technologies, but just be able to move it into a cloud environment and maybe then bring it back in-house. And we have the same use cases as well, where we have some of our customers who started out, for example, in a public cloud and tested out, say, some of their services, for example, some of their products. As they gain popularity, grow beyond the point where it's actually financially sensible to run them in a public cloud, then move them in-house, for example. Or if you needed to have a guaranteed SLA a cloud provider couldn't achieve, you move them in-house because you have then more fine-grained control here. Also, again, some countries may be unstable. For example, you have to tear down your services, move them elsewhere, those kind of things. As you have standardized your infrastructure, it allows you to do these things much, much easier over time. And there's a huge amount of new solutions out there with cloud computing. There's like, everything as these days, where basically you have software as a service offerings left and right. I should have put up the picture. If you walk through some of the Canadian airports, there actually is a Cloud9 liquor store. So you can have alcohol as a service, which I think is probably one of the best models so far, and probably makes the most sense to most of us. But I think it is really important to also understand on what real sort of these service offerings are, because again, a lot of these terms are being thrown around, often with very little to no context or abused context. It all started out with, again, infrastructure as a service, which was not too hard to abuse, but then already it's platform as a service. There's a huge divergence where platform as a service can be as simple as, I just want to provide a VM with a compiler in it. That's platform as a service for me. Our definition of platform as a service is, of course, a much more complete and complex configuration around, say, OpenShift, for example, a true developer service where the developer actually also can have control around deployments, around scaling. So again, just always do sort of the finger test around, well, what does the vendor mean? What do they tell me versus what I, for example, my perspective is around this. You also now, with, again, these different environments, have more need or a higher need for cross-architecture management, meaning managing your local data center, your local infrastructure, and a remote data center, and maybe a public cloud, but again, common management tools, common management framework. And as Jim said earlier today, data is becoming more and more important. Data growth is tremendous right now, but a lot of the data often will just sit out there and not be used because it's just aggregating way too fast, or that you don't have the tools to use it. Cell phone companies are a good example around, for example, their short message service. A good portion of their cell phone service records may not be used because they produce gigabytes and gigabytes per second, where it just is noise in their revenue. But if they could mine it, for example, and be very, very effective, they could make additional good amount of revenue on it. But again, today there is just not yet all the tooling in place, but I think you see some of the technologies emerge and being really interesting for a lot of those things. I mentioned it, SLAs, quality of service, become extremely important and are tightening much more than they have before. And that's also, I think, with Amazon, where with Amazon, sure, you get a virtual machine, but you don't get necessarily a watertight SLA or quality of service as you would expect it from, for example, your own IT organization. Sure, you get a refund for the hours you may have lost if there's an outage, but it probably doesn't reflect your true loss in terms of money from an outage. And also quality of service, there is not really a guarantee for throughput, for example, as you might be able to guarantee in-house. So you need to understand on what are your requirements and can you address them with different solutions, for example. Clearly, efficient use of your infrastructure is really important. You want to drive up the utilization as much as possible from sort of the traditional 30, 40, whatever percent it might be to 70% and higher, and be able to reprovision infrastructure resources to where they are needed. So you can get rid of those purposely built pools of resources. For example, virtualization being a good example where, yeah, you have a pool of servers which are for virtualization, pool of servers which are for bare metal, for example. Today they are totally exclusive, not easily, for example, interchangeable, but there are use models where maybe you could just have a single set of servers and just disable virtualization on the fly, for example, and run different workloads on it, or mix and match bare metal workloads and virtualization. Because again, we all love everything being virtualized, but reality is there is still quite a good amount of applications out there which are not virtualized and which may not be virtualized in the short-coming time. So we need to cater also for bare metal infrastructure. And I think Jim touched on it earlier in his keynote around common infrastructure services, actually Paul it was, sorry, around common infrastructure services where you don't want to re-implement the same services over and over again for different infrastructures, being it, for example, as I said earlier, HA, high availability. You'd be able to just leverage a service in each and every infrastructure, but it's the same service across of these infrastructures, and it can orchestrate across of these environments. Same with storage. You would like to be able to use a common service across all the infrastructures for storage and just define policies on how replication, for example, is being done, how you want to move data from point A to B, where data can reside, where you, for example, start, stop services based on latency, cost of compute. Those kind of things are really, really important. Same for messaging. A messaging backbone becomes really important now to provide sort of a uniform platform where you can just have a common message bus across infrastructure just attached to it from your application, but again, don't have to build a messaging infrastructure in every single infrastructure. So standardization, and we've prayed standardization for a long, long time. We already have a lot of customers who bought into the early days, what we did around satellite, for example, and Red Hat Enterprise Linux around system standard builds, very successful. Again, build environments where you can repeatedly build your infrastructure, repeatedly deploy infrastructure, but not have to sort of spend a lot of manual labor on doing it. But it also allows you to be much more agile, because suddenly as you standardize your build process, as you standardize the bundling of applications and OSs, it allows you then to, for example, very quickly to move resources from environment to environment. You no longer have to think, oh, now I need to move it here. Now I need to do all these special tasks to do it here versus the other special tasks over here. If it's standardized, for example, you might have one set of definitions and they apply everywhere, for example. Again, common interfaces being common APIs. We are very, very passionate about common APIs, open APIs, having a reference architecture around APIs. So you probably heard all about Delta Cloud for the past couple of years around management for infrastructure, where we built out this infrastructure-independent API called Delta Cloud, which allows you to do virtual machine lifecycle across multiple infrastructures, but have a common API to access infrastructure services without having to use all of the specialized tools for each and every infrastructure, for example. It also allows you to reduce the time, for example, to test and certify. So as you have a common environment, you can, for example, be assured, well, if I deploy it on my standardized infrastructure, I know it will just work out of the box. I don't have to retest everything over and over again, for example. And as earlier, refocus some of the skills. Move them from sort of the mundane system admin tasks higher up in the stack and give them, for example, ability to be more meaningful to the business, contribute to some more functionality, value-added functionality higher up in the stack, for example. And again, we believe really open source has shown already its success and will continue to do so over many, many years to come. I think I covered a lot of this already, so in the interest of time, I probably should move forward a little bit. So what are we doing with Red Hat here? So clearly, we built a lot of stuff already around Red Hat Enterprise Linux. It's been deployed everywhere. I don't think anybody would challenge me on any workload can't be run on Linux anymore. We have all the examples from anywhere from single core to largest systems you can imagine, running your workloads. There's a tremendous ISV portfolio available today on Red Hat, for example, and that's really important. Today, the development platform for pretty much 99.9% of the ISVs is Windows and Linux. They're the first port, and all of the classic enterprise Unixes now have become literally second tier. Which is great for us because, again, you don't even, and it's great for you because you don't have to worry about, oh, is the application available on Linux? There are some applications which are still sort of moving slowly to Linux, but they're often very focused for a specific industry segment use case, and the ISV certainly often sees the need to move it to Linux, and there are lots of services from us to do this as well. But it also allows you to, again, use commodity hardware, x86 servers. Again, I don't think anybody would challenge their capability today in terms of reliability, for example, serviceability, scalability. All those x86 servers surpass typically today what we have been used from traditional x86 servers. Also, we support not only our own hypervisor, but we support all of the common hypervisors out there with RHEL. So we, of course, want to be a really good guest on VMware. We run well in a number of the cloud providers, especially if it's a cloud, certified cloud provider as part of the Red Hat Cloud program. You can also not only be sure the operating system itself runs, but we also have the business side in place where you can move your subscriptions from on-premise, for example, into a cloud environment. And again, as I said earlier, maybe looking at something like KVM allows you to look at some of the new use models. As I said earlier, maybe it allows you to now suddenly, hey, I've got a common server farm. All of them have KVM because it's part of RHEL as it ships out of the box. And there's no need to enable, disable KVM really because it doesn't take up any resource if you don't start VMs. But you can on demand start up VMs in your infrastructure, move them around as long as you satisfy a minimum set of requirements. say, shared networking, shared storage, but suddenly can create this bigger common pool of servers and move, for example, VMs, start VMs, not only based on availability, but also use cases where you might be able to start some VMs at night for certain tasks. And we actually do have customers who've done something like this around workstations, where they run today RHEL on their workstation. They have some very beefy workstations on their desktops today. And at night, they're all sitting idle and just burn power, basically. But they use these workstations, spinning up virtual machines, and use, for example, them for number crunching, cycle harvesting, you name it, using our technology called MRG, where they use the G-component grid, which allows you then to do job scheduling, virtual machine scheduling across a large infrastructure, for example. So, and Paul showed this slide today already. There's a lot of stuff we've done in Red Hat beyond Linux. We acquired JBoss, it seems to be a long, long time ago, again, where we moved into middleware. We acquired Kubernetes with virtualization, Makara with OpenShift, for example. Actually, Metamatrix we also acquired, which have become the foundation to a lot of the data services we have now built into the JBoss portfolio, and the latest acquisition being Gluster around storage. And it just shows you, again, how really serious we are around infrastructure and not just being Linux, but giving you a much, much broader choice on the product side. So this is just sort of a typical infrastructure platform where you would like to have some management systems, for example, some Linux, Red Hat Enterprise Linux, some PaaS capability, maybe some infrastructure as a service. And in the past, we would have filled like the middle block with Linux. I mean, today, we can fill pretty much all of these boxes already with existing and shipping products. So on the left-hand side, for example, under management systems, we not only have the virtualization part, we also have Red Hat Satellite, which has been around for many, many years, very successful, very, very robust product, used to deploy thousands of systems in customer environments, is used for lifecycle management, compliance management, and we are now starting to ship the next generation of the product under the umbrella called CloudForms. You may have heard about something called System Engine, which is over time going to be the next generation satellite product and allowing you not only to do bare metal provisioning, but also virtual machines and across different environments, for example. Then you have JBoss with the entire application portfolio, enterprise messaging, for example, web services, Java platform, application monitoring, deployment via John, for example. So a very, very comprehensive environment. Obviously, there's Linux here. We have Gluster now for storage. And again, Gluster is the same thing. Today, we have it as a storage offering. And as we move forward, you will see Gluster being more and more integrated into the product. I think Andy Castro mentioned it. We are integrating Gluster into our Red Hat Enterprise Virtualization product. So actually have a single look and feel as the end user, as the system admin, from the graphical user interface. You can now manage storage and virtualization with the same tool set, for example. And then underneath, there will be policy in place over time where you might be able to define replication policies. So if data is read in a certain location X number of times, you might say replicate the data over here, for example. Built-in multi-tenancy on the storage layer, really important. And I have a slide on storage in a minute. I'm giving you a couple of other ideas on what might be possible to do around storage, because again, it's based on a standard RHEL instance. It's not a special RHEL build, for example. OpenShift, obviously our platform as a service offering, which we have now open sourced as OpenShift Origin, and we are going to provide a productized version for on-premise over time. But with OpenShift Origin, we give customers the ability to very early on now get access to the technology, bring it in-house, start it up in-house, and give us, for example, feedback on what is important to you in terms of functionality, capabilities in this product. And obviously, CloudForms we launched as a product already, which again gives you this umbrella management framework across multiple infrastructures. So for a stack itself, really you could envision a stack being OpenShift as sort of platform as a service on top. You have some middleware you might be, for example, deploying as part of your application development. You could look into, and I'm not talking a lot about it, into Red Hat Enterprise Merge, messaging, real-time, and grid, where really messaging and grid are probably the most interesting ones to most of you, where messaging gives you like this common messaging infrastructure, similar like a typical messaging infrastructure, based around AMQP, public subscribe mechanism, very, very well used in financial services, lots of other environments, but it gives you the ability now to commoditize your messaging infrastructure. Same with Grid. As part of Grid, we have an offering which, again, has been proven by a number of large customers. One of our official customers who won an innovation award last year for the use of Grid is DreamWorks, where they run their entire rendering farm on, for example, Grid. So just the showcase for us was actually Madagascar 3, the movie just released 2 weeks ago, was the first movie from DreamWorks completely rendered using Merge Grid, which was great because we outplaced a competitive product. But again, they start with RHEL over the years using virtualization and Grid, so they start leveraging more and more of our products over time. And then you have Linux, cluster storage, for example, virtualization. All of these things are important here. So let me move forward to some of the products here, so otherwise we run out of time, I bet. So for storage, as mentioned in some of the storage talks already, as actually, unfortunately, ClusterFS talk is, overview is right parallel to this one, but we announced the storage product, Red Hat Enterprise Storage. It's based on a standard RHEL build, really important. It's not a proprietary RHEL kernel, which would be different to any other RHEL kernel. The same RHEL kernel we use in standard RHEL, we use with our virtualization product. Leveraging x86 server hardware, building storage pools, for example. And it enables you now suddenly to build cheap and cheerful storage farms if you want to, and look at some of the new use models around big data, for example, data analysis, running Hadoop, which in the past you may have not been able to. Replication, it also addresses maybe some of the needs you have around, I would like to use, say, Amazon, for example, AWS as an environment, but how do I get my data back and forth from this environment? Well, now, with Red Hat Enterprise Storage, you can do this because it actually runs as an appliance. You either run it as on the server, you just install an ISO image, or you can take the ISO image, run it as an AMI, for example, in Amazon. You run exactly the same software and can replicate between Amazon, for example, or wherever you run this virtual image. It can be any other cloud. We actually have a customer who just for fun spun up a Red Hat Enterprise storage instance in the HP cloud and replicated back into their ref environment, and took him less than 2 hours to do the entire setup, and he was totally blown away. He actually thought it's not working because it went so quickly and just worked out of the box. But it just shows you now suddenly you have an environment where you can actually replicate your data seamlessly between these environments and not having to worry about, well, how do I get this back and forth with NFS, FTP, whatever it might be, for example. And as Jeff Darcy, I believe, mentioned already, it also allows you, if you're interested in some lower layer activities, really, for example, doing something which is important to your environment, you have some special needs on how you want to present data, massage data as it's in transit. Gluster is a great example where it allows you to build your own what is called translators, and you can, for example, translate data while it's in flight to storage. So we have a use case, we have a customer with a data center here in the US, data center in India, but they want to do some data modifications on the way between the US and India, for example. So they would just build a translator and be able then to plug this into Gluster, transparent to all of the applications, so no applications changes needed on their side. So that's just a very high-level Gluster diagram. You hopefully have seen this already in the past. Take a couple of x86 servers, locally attached storage. Again, today SATA storage, cheap and cheerful. You get lots of terabytes for very little money. You can use SSD as well. You could also use some fiber-connected storage, but really that's besides the point because you want to build a cheaper and more scalable infrastructure. But now, as you're running a standard RHEL instance on your Gluster storage host, it allows you to leverage maybe some of the traditional Linux capabilities, such as, for example, C groups, control groups, or container technology. So, and that's something we are looking at. We actually supported, I believe, as tech preview now in the Red Hat Enterprise Storage product using Hadoop. where you can actually run Hadoop jobs locally on the storage appliance. So suddenly, you actually run your application job on the storage array, which is a tremendous change from in the past, where you run your storage totally separate from your applications. So you gain efficiency, resource utilization much better. So very interesting use case. But again, as I said earlier, all the other interesting use cases around where you can now do resource capping on the storage appliance, where we can build these resource groups with C groups around these jobs. And C groups is, for example, a very fundamental capability in RHEL, which is now propagating throughout the entire stack. It's not only used in our storage infrastructure. We will expose it in Red Hat Enterprise Virtualization. We will be able then to define, for example, quality of service policies around virtual machines. We are also using it already today in OpenShift to, for example, build resource containers around the developer instances, which is a great use case because if you look at OpenShift, everybody believes, oh, I'm running my own instance of RHEL, for example, but in fact, all you get is a slice of RHEL carved out with SE Linux and C groups, which allows us to run multiple hundreds of developers on a single instance of RHEL, so we don't need to deploy 1,000 virtual machines, for example. And that's just the use case here, where you have your local cluster infrastructure, for example, in your local data center, and then you just have appliances in EC2, for example, do replication between them as you see fit, but it allows you to easily move data across these environments. And again, benefit here is single namespace. You don't have to think about, oh, well, where are files? It's a single namespace for you, and you just define the replication policies for it. So for virtualization, I mean, virtualization, everybody has a virtualization project. Everybody has virtualized a lot of their infrastructure already today. But we just released Red Hat Enterprise Virtualization version 3 a couple months ago, very mature platform. I think very feature complete, very much closer to its competitors than it has been in the past, but at a much lower price point, for example. Can run not only RHEL, but also Windows guests. But again, it allows you now to look at maybe additional use cases. We allow you to run server desktop virtualization on the same platform. You don't need different environments for it, for example. You can drive the entire infrastructure via a very simple REST-based API. And we have customers who decided, I know better on when to move virtual machines, what to do in the infrastructure than Rev itself would know. So we allow this via the API. Everything you can do via the UI is available via the API, for example. And you get a portal. So for those customers who want to build a private cloud, perfect solution. You already have virtualization. You get a user portal. You can define pools of resources. Users get virtual machines assigned. They can provision them. Works great. And then it's also now integrated with cloud forms and storage, as I said. So Gluster not only as underlying storage for the virtual machines, which is great, but you can run Gluster as a storage appliance inside your virtualized infrastructure. So this, for example, would allow you might want to have some virtual appliances, storage appliances in, say, your VMware infrastructure, some of them in Rev. It would allow you to seamlessly move your data between these infrastructure without having to go through the hassle of different device naming, how is storage being handled, all those things, because it would be just contained in virtual containers. And we do have, again, customers who have started projects on re-architecting some of their infrastructure to, for example, leverage Gluster very actively. For some of the workloads, it lends itself very well to, like, for example, large number of large PDF files, lots of read-only access. So highly recommend to look at. Cloud Forms the same. If you need a more comprehensive self-service portal with finer controls, more delegation, better provisioning capabilities, application bundling to it, for example, Cloud Forms would be a great solution to look at, just layers on top of Rev, but you don't have to necessarily buy the entire stack. You can just start wherever you feel it's comfortable to you. And that's just a very simple diagram on how, for example, Gluster would fit into this picture just for virtual machine storage, and then obviously you can envision as you run Gluster as a virtual storage appliance, how it fits into your VM infrastructure as well. So CloudForms, there have been many talks on CloudForms. I'm not going to a whole lot of details here, but again, allows you to do cross-infrastructure management. So not only ref management, doesn't replace ref management or, for example, VMware's management, because CloudForms doesn't want to replace the vendor-specific way of managing the actual infrastructure, how storage is assigned, how networking is managed. That's always very specific to a given infrastructure and should be. That's perfectly fine. But the higher level abstraction should be common across all of these infrastructures. So being able to bundle an application and an OS, and just at deployment time, certain special tasks will be performed, such as adding drivers, making configuration changes, for example. But it should be all black box for you. You should not have to worry about which driver do I need to run in VMware, for example, which modifications do I need to make to my virtual machine definition if I run it in Amazon. This should be just happening as part of the deployment. So as you define a deployment, you just select the targets like EC2, Ref, VMware, and it just happens on the backend side. But again, you can concentrate on how do I bundle my application, how do I bundle my OS, how do I configure it, or describe it in an XML file, and again, do this common across many infrastructures. It supports today on-premise, such as VMware and Ref, for example. We also support public cloud providers, such as Amazon, and it's built on a pluggable module using drivers. So in theory, it's very easy to add other capabilities to CloudForms by adding just more drivers and certifying them over time. And you can do a lot of customization for pre, post-boot, for example. You've got all of the stuff you need around user, admin portal, so you can define resource pools, pool administrators, all the stuff you would like to see. You have a monitoring part to it where you can monitor all the utilization. We actually just announced, I believe, also at the summit, James Lebocky may have done this already, a partner with Splunk who built an appliance to aggregate, for example, log files across the infrastructure and allow you to do some really interesting reporting. And again, Splunk is a great example as a partner where it will allow you to, for example, set markers in your log files, and then you could actually very easily trace an application flow from the request coming in, going all the way through your web server, middleware, wherever it is. But Splunk would allow you, for example, to do all the data mining really effectively, very, very good. So it's a great tool to look at if you haven't looked at it yet. And that's just, again, the diagram for CloudForms, and not spending a whole lot of time on it, but you get the idea where basically you have your management framework, you have the infrastructure management API underneath. You could now envision cluster as the storage for cloud storage, where suddenly you have a storage pool which crosses many infrastructures, but you don't have to know where actually individual storage entities are because you have a global namespace, and just based on the policies you define, storage will be replicated to certain locations, and you can, again, define policies such as locality, cost of compute, security concerns, whatever it might be. So OpenShift as the last part, the platform as a service part, and platform as a service, Paul, I think, mentioned this today. There's sort of this emerging model around DevOps, developer operations, coming, and I think this was actually pretty good. And unfortunately, William Henry is not here, a co-worker of mine. He does a lot of work on OpenShift today. He actually looks like the most interesting man at the Red Hat Summit. But he had to go to Colorado. His house is burning down right now, so that's not good. No, it's not. It's only smoke around, so I shouldn't joke about this, but no, it's not fun. But DevOps brings some interesting new ways how you might run, for example, your infrastructure. For those of you who haven't looked into DevOps, haven't done a lot around it, I highly recommend to watch. There's a YouTube video from the CTO of GitHub talking about DevOps and how they operate DevOps. And if this is not the most scary video you will ever see around IT management, then good luck. But it's very interesting because he actually explains on why it still works great for them to compile and run directly in production, for example. And yeah, things will blow up over time, but it allows them feature velocity at a rate which was unheard before, for example. And other ways, scaling, for example. All these things you may have not been able to do in the past. And OpenShift, we will allow you different models. You may say, hey, I want to give my developers all the freedom around deployments, around scalability, for example. They can go wild as they want to. Or you might say, no, they should not be able to spin up new instances without approval, for example, without being able, me saying yes or around some business rules. So we will cater for both sides, on the IT ops side as well as the dev ops side. So you will see OpenShift rolling out over time with also an on-premise version. So today we provide the free developer service. Maybe over time there might also be other services around OpenShift. As an Origin is available today, you can download it, get it started, play with it, for example, give us feedback. And again, just shows you on how you are able to participate in the process very, very early on. And as it's based on the concept of cartridges, you can actually even write your own cartridge to plug in if there would be a programming environment which we don't cater for today, say Java today, PHP, Ruby, Python, you name it, but there might be other cartridges you are interested in, and you can just write your own and plug it in. We actually had one customer in the free service actually wrote a COBOL cartridge. I'm not sure how many of you would say COBOL is like a Web 2.0 language, but it allows you to do this, which is really cool, and again, allows you to create sort of this breadth and reinforce what we said earlier, no lock-in. We don't want to dictate which programming stack, programming framework you have to use, but you have the choice of the framework and the tools you're using. And in the end, sort of the complete stack would look very much something like this, where basically you have, let's say, a platform as a service capability on top. With OpenShift, you have cloud forms for the hybrid cloud management, virtual machine lifecycle management, compliance management, configuration management, all those things would be on the cloud forms layer. Red Hat storage, as you've seen, would fit into a number of areas, being it as a virtual instance or being as back-end storage, giving you the ability now to move data seamlessly between environments and define policies around it. You have JBoss middleware, which runs everywhere, really. JBoss middleware wouldn't care if you run it on Rev, you run it on VMware, Hyper-V, whatever it might be. So again, it allows you to pick whichever infrastructure works best for you. Same with RHEL. RHEL runs well on all these hypervisors. You can pick the hypervisor, whichever you feel is the best for you. And then obviously you also want to cater for your physical system. So while today with CloudForms we don't yet allow you to manage physical systems, it's something we are thinking about and want to enable is to also cater for physical systems. So on the provisioning side with Satellite, we already do physical systems today, but there's lots of other stuff we could, for example, leverage with physical systems and then give you the ability to span the entire infrastructure and the entire stack of your infrastructure. And also then move this out to third-party clouds as well, as that all the management tools work seamlessly across this entire stack of technology. So probably just to quickly wrap it up is, again, building your next generation IT infrastructure is not just a simple part number. Even just building a cloud infrastructure is not a single part number. It is really an evolution. We firmly believe it's also not going to be a rip and replace capability. You really want to leverage existing investments, existing infrastructure, and gradually enhance it, add to it over time, which we certainly support with all the technology I just mentioned today. Again, open source, replacing a lot of the proprietary components at a much lower price point, more faster features. If you look at virtualization, what Rev has achieved in the last 3 years is amazing compared to other capabilities out there for a long, long time. RHEL has matured today where I think nobody would argue with me there is functionality in enterprise Unix which is not available in equivalent functionality in Linux today, and Linux is moving forward much, much faster. Also, a lot of the problems in Linux in terms of next generation system architecture have been addressed in the past on RISC platforms. I always say there are no new problems, they're just people who haven't met. And the people who fix the problems today have fixed these problems in the past on, for example, enterprise Unix, which is great for us and great for you because it's not like, hey, I have to think about this 15 times over again. I can do something similar I've done in the past, for example. Again, it's more rewarding for sysadmins, engineers, where they don't have to spend necessarily as much time on mundane tasks, repetitive tasks, but look at higher value added capabilities, for example, be more meaningful to the business. And again, feature velocity overall from open source, I think, is unsurpassed, but also capabilities adopting to new use cases. If you look at the availability of tools in the open source world, it's just amazing on how much new stuff comes out. And you might just try it out and then, it wasn't the right thing, try the next tool, which is perfectly fine, but at least you have choice and you can use a lot of these capabilities. And here are just a couple of pointers on what might be of interest to you. I think Vijay Trian might be still in the audience, so you can talk to him later on. He has a whole program around reference architectures where we actually document today really on a product stack basis, step by step, down to the command line level, how you deploy, for example, Red Hat Enterprise Virtualization and JBoss, how you deploy CloudForms and JBoss, for example. So really, really valuable site for very, very interesting documentation. A couple of videos around how you move from virtualization to cloud, how you can build a cloud, for example. Pointer to OpenShift Origin, a couple of other things. So obviously, if you have any questions, you can ask them now at the talk, or send us email as well. We get back to you at any very, very soon. Important thing before I forget, I've got the important game code. Not sure what you win, but 1676 is the magic code to type in, and you win something really cool, I believe. So with this, I think I'm just about on time. We've got like 45 seconds for questions. But no, I'm here for a while, so don't worry. So I hope this was informal, was fairly high level, but we plan to build on this and drill down further into technology, integration, also provide more examples around integration, maybe even bring up like a site where there would be some scripts on how to integrate some of these components as well. So are there any questions? Everybody's ready for drinks by now, I bet. So. Good. Well, then, thank you very much for being a patient audience. And we see you next year. Actually, you still have tomorrow, so that's good.